Our solar system has always been a crossroads for interstellar travelers, mysterious objects that originate from other star systems and pass through our cosmic neighborhood. While many of these objects simply drift through without causing any disturbance, but some, especially those the size of planets or even stars, can leave a significant impact on our solar system's structure. There has been much debate and speculation about these interstellar visitors. Some scientists believe they are just natural space debris, while others suggest they could even be artificial spacecraft sent by intelligent civilizations from distant planetary systems. The idea of alien technology or unknown cosmic forces influencing our solar system has sparked curiosity and controversy among astronomers. In today's video, we will explore some of the most intriguing interstellar objects that have passed through our solar system. More importantly, we'll discuss an exciting new study that suggests a massive interstellar object, possibly as big as Jupiter, may have dramatically reshaped our planetary system billions of years ago. How did this giant object enter our solar system? What effects did it have on the arrangement of planets? And could it have played a role in shaping the solar system as we see it today? Join us as we analyze this fascinating discovery in detail and uncover the secrets of this ancient cosmic intruder. Consider this. Billions of years ago, our solar system started as a huge, cold cloud of gas and dust floating in space. Over time, gravity pulled parts of this cloud together, causing it to collapse and form the early sun. As the sun took shape, the leftover gas and dust around it didn't just disappear, it began spinning, flattening out into a giant disc-shaped cloud called the protoplanetary disk. Inside this disk, tiny dust particles stuck together, forming bigger and bigger clumps. Over millions of years, these clumps grew into asteroids, moons, and eventually the planets we see today. As we can see, all the planets were born from this same spinning disk. They naturally continued moving in the same general direction and in nearly the same flat plane around the sun. And this is why, when we look at the solar system from the side, it appears mostly flat, like a thin disk with planets neatly orbiting in a line. But wait, scientists noticed something puzzling about this theory. According to their models, most planets should have formed much closer to the sun than where they are now. But if that's the case, how did they end up so far away? This mystery puzzled scientists for decades. To explain this, they developed a new theory called planetary migration. This theory suggests that planets didn't stay in their original positions. Instead, interactions with leftover gas, dust, and even other planets caused them to slowly drift to new orbits, some moving farther from the sun and others shifting inward.
For example, Uranus and Neptune likely formed closer to the sun, but later moved outward to where they are now. Meanwhile, some smaller planets that were forming got thrown out of the solar system altogether. Well, this planetary migration theory helps explain to some extent why the solar system looks the way it does today. However, there are still some unanswered questions left, like the orbits of the gas giants like Jupiter, Saturn, Uranus, and Neptune aren't perfectly circular and show strange patterns that current migration theories can't fully explain. These irregular orbits suggest that something else may have happened in the past. Surprisingly, a recent study published on December 5, 2024, by Garrett Brown and his team sheds new light on the eccentricities in the orbits of these gas giants. Their research introduces the intriguing idea of interstellar flybys as a potential explanation for these oddities, offering a more satisfying answer than current migration theories. Brown and his team suggest that the configuration we see today may not be the result of internal mechanisms alone, but could also be influenced by something much larger passing through our solar system. According to their calculations, if an object between 2 to 50 times the mass of Jupiter flew within 20 astronomical units away from our solar system's center, it could account for the unusual orbits of the gas giants. Through computer simulations, they estimate the odds of this happening at 1 in 100, which is fairly high for an event of this nature. Currently, this is only a proposed theory to explain the unusual, eccentric orbits of the gas giants in our solar system.
You might think this is just a theory, and that the chances of a massive object passing through our solar system in the past are very low. But here's the surprising part. Scientists have gathered strong evidence showing that many giant objects have passed through our solar system over time. And even more astonishing, research suggests that a star once came very close to our solar system in the past.
In 2013, during one of his regular visits to Santiago, Chile, Professor Eric Mamajek of the University of Rochester was shown an interesting discovery by a fellow astronomer, Valentin Ivanov. The finding involved a nearby star nicknamed Schultz's star. This star caught their attention because it seemed almost motionless. Typically, stars shift slightly across the sky each year, a movement measured in tiny units called arc-seconds. But Schultz's star hardly moved at all, even though it was only 22 light-years away, a close distance by cosmic standards. Mamajek realized there could only be two explanations for such behavior. Either the star was heading straight toward us or moving directly away. To solve the mystery, they examined its Doppler shift. A shift toward red would mean it was moving away, while a shift toward blue would indicate it was approaching. After some quick calculations, Mamajek confirmed that the star was moving away from us at 80 kilometers per second. This meant that about 70,000 to 80,000 years ago, Schultz's star had passed extremely close to our solar system, within just 1 light-year. For comparison, the closest stars to the Sun today, the Alpha Centauri system, are about 4 light-years away. Schultz's star passed through the outer edges of our solar system, even grazing the Oort cloud, which is a region of icy bodies surrounding the Sun. This was a rare and extraordinary event, as no other known star has come this close to the Sun in recorded history. This finding supports the idea that, in the distant past, interstellar objects as massive as stars may have passed through or near our solar system, disrupting the arrangement of planets with their gravitational pull. Even more fascinating and potentially concerning is that such events are not rare. Astronomers estimate that a star passes through the Oort cloud roughly every 100,000 years, and a closer encounter within 52,000 astronomical units might occur about once every 9 million years. These near misses could significantly impact the solar system, potentially altering the paths of comets or even planets. This discovery raises important questions. Could another massive object pass near Earth in the future? How might it affect our solar system? While such events are rare on human timescales, they remind us of the dynamic and ever-changing nature of the universe. However, this new theory suggests that even the Sun's powerful gravity may not be enough to protect us from disruptions caused by large, foreign objects from outside the solar system. This kind of event could have thrown the entire arrangement of planets into chaos, demonstrating how vulnerable even our well-ordered solar system might be to the influence of interstellar objects.